Lesson 35, Hypothesis Testing Procedure for Two Population Means. Now, to conduct a hypothesis testing procedure involving two population means, the following steps can be used as a guide to help us in the hypothesis testing procedure. Hypothesis testing procedures begin with the formation of a hypothesis. The stated hypothesis must be expressed in a form that can be tested statistically. Now, this involves selecting the paired forms of HO and H1 that correspond to the stated hypothesis. There are three pairs. Either the HO H1 is mu1 equals mu2, or mu1 does not equal mu2. Or the other form is the HO H1 of mu1 greater than or equal to mu2, or mu1 less than mu2. Or the third pair is the HO H1 of mu1 less than or equal to mu2 versus mu1 greater than mu2. So one of these three pairs will correspond to the stated hypothesis. One of them, either HO or H1, will indicate that that hypothesis is valid, and the other one will indicate the opposite. The hypothesis is not valid. Now, unless there exists a compelling reason to do so otherwise, hypothesis testing procedures are conducted using the customary 5% level of significance, that is, alpha equal 0.05 decimal. Now, after the random sample data from the first population and the random sample data from the second population have been entered into separate lists, or the sample statistics x bar 1, sx1, n1, and x bar 2, sx2, and n2 have been determined, the 2SAMP t-test command on the TI-84 calculator will calculate the desired p-value for the hypothesis test procedure. To do this, we press Stat, arrow over to Tests, and arrow down to the 2SAMP t-test command. Enter. Our choice of input is either the data or stats. If stats is selected, we need to enter in the statistics, the x bar 1, sx1, and n1 from the first sample, and the x bar 2, sx2, and n2, the sample statistics from the second sample. But instead of having statistics to enter in the calculator, instead we could have the actual sample data that were entered in lists. So to do this, we need to put the cursor on the data and press Enter to select data as our input. In this case, we then designate list 1 as the list that contains our first sample of data. List 2 is designated as the list that contains our second sample of data. Freq 1, Freq 2 are, for purposes of this lesson, going to be 1 because the sample data comes from one sample subject. And then the alternative includes either a not equal, a less than, or greater than inequality. We need to select the one that corresponds to the H1 in our hypothesis. Pooled is going to be no for the purposes of this lesson because we're not going to do the more advanced technique of pooling the results. Then we down arrow to calculate, press Enter, and the results of the 2SAMP t-test command are displayed. The p-value is the one that we need to reach our decision. So the p-value, the one that states that p equals, is the one that's used to reach the decision. Now, the formula that's programmed in the 2SAMP t-test command is given here. The standard score for the difference in two sample means is used as the test statistic for this hypothesis testing procedure. The corresponding p-value is calculated using the results of the central limit theorem. Therefore, in order for the normal approximation to be reasonable, either both sample sizes must be sufficiently large, or the distribution of both populations from which the random samples were selected need to reasonably follow a normal distribution. So, if both sample sizes, N1 and N2, are greater than 30, that is, they're sufficiently large, this hypothesis testing procedure can be applied. But if the sample sizes in either sample are not sufficiently large, then we need to further make the distinction or assumption that the distribution of both populations follow a normal distribution in order for this normal approximation of the p-value to be reasonable. Now, the calculated p-value is used to reach a decision regarding the validity of the form of the hypothesis indicated in HO. Small p-values provide sample evidence contradicting HO. Large p-values provide sample evidence consistent with HO. Now, when HO is rejected, that is, the p-value is less than or equal to the alpha, the form of the hypothesis expressed in HO is considered invalid. Consequently, the form of the hypothesis expressed in H1, which is the opposite of HO, is considered valid. When HO is not rejected, that is, the p-value is not less than or equal to alpha, the form of the hypothesis expressed in HO cannot be dismissed. That's because it possibly might be true. So careful consideration must be given when interpreting this decision. That's because either HO cannot be rejected because HO is valid, therefore we do not reject our valid ideas, or because there is not enough sample evidence to clearly indicate that HO is indeed valid. That is, HO may be invalid, we just don't have enough sample evidence to clearly indicate that. So, based on the interpretation of the decision reached in the hypothesis testing procedure, that is, whether we reject HO or do not reject HO, the last step in the hypothesis test procedure is to state an appropriate conclusion based in terms of the issue under investigation. That is, using words of the problem to interpret the result of the decision. The following examples will help demonstrate a hypothesis test procedure for two population means.